Close your eyes for 5 seconds. Now imagine living like this for the rest of your life. Difficult, right? According to a 2020 estimate by the IAPB, 1.1 billion people globally have vision loss. At least 771 million of these individuals have preventable or repairable vision loss. Diabetic retinopathy affects people with diabetes, rounding to 28.5% in the United States and 18% in India. Most guidelines recommend an annual screening for people with mild or no DR, a follow-up exam in 6 months for those with moderate DR, and an ophthalmologist referral for treatment evaluation within a few weeks to months for those with severe DR. In developing countries like India, there is a shortage of about 80,000 eye doctors. In developed countries like the US, about 20 million people do not have any health insurance coverage. Furthermore, even if they have health insurance, it usually covers only one eye checkup annually. Since eye tests and doctor appointments can be costly and time-consuming, people generally fail to make timely consultations. This implies that early detection and diagnosis are severely hampered. But there may be a solution to this problem.
We present to you iLenz, an AI-based tool that enables users to perform retinal imaging through mobile phones, promoting periodic eye checks from the comfort of their homes. The predictive analytics and AI algorithms deployed on iLenz empowers its users to detect eye diseases early, reducing the risk and expense. It distinguishes itself from current systems because of its user-friendliness, enabling usage without any medical knowledge and providing a dilation-free experience for regular monitoring. Let's meet Jake Paul.
Hi, I'm Jake. I'm in my early 20s. I'm the sole earner in my family and I believe in regular monitoring to catch early signs of diseases. I have a family history of diabetes, but I have no reliable tool to monitor my eyes regularly. Every time I want to get my eyes examined, I have to wait a few days for appointments. Whenever I do get my eyes tested, I have to waste the complete day because of the blurriness and increased light sensitivity from dilation. iLenz is one such tool which enables me to regularly monitor my eyes right at home without the need for dilation. To start in on the platform, I need to sign in on the iLenz app. I then proceed to my profile. iLenz provides an option to create multiple profiles, ensuring that my whole family can use the same device. Next, I start capturing the retinal images after attaching the clip-on lens hardware on my smartphone camera. Once I have successfully captured the images for both eyes, I proceed to the analysis of these images. The deep learning models on iLenz have detected signs of diabetic retinopathy in my eye. The severity is moderate, so I don't need to take any immediate steps. I can even download the analysis reports and take it to the ophthalmologist for the next steps. iLenz also allows me to access my past reports from the History tab or bookmark them.
iLenz leverages state-of-the-art deep learning model architectures for disease detection and severity grading. The models are trained on open source datasets from Masida to RFMID and IPEX, which contains thousands of ophthalmologist-approved, de-identified annotated fundus images with different levels of severity. iLenz ensures security on the platform by implementing 128-bit encryption and JSON web tokens. The user's privacy on iLenz would be upheld by maintaining de-identified data and enforcing a confidential level of security clearance, ensuring compliance with HIPAA rules and regulations. The whole team has completed IRB training for human subjects research and are in the process of getting an IRB approval. For more detailed information, you can refer to the documentation. In the prototype phase, we have already accomplished detection of 4 eye diseases with an accuracy of 85%. The model confidently estimates 5 levels of severity for these diseases with an accuracy of 70%. The future timeline includes setting up the user interface and deploying the stable build on AWS while maintaining a database to store the user credentials and other details. We are in constant dialogue with onboard medical experts who guide us with the testing phase and validate the results. The clip-on case will be printed using a 3D printer available at the University Innovation Center. In the future, this application will recommend personalized preventive measures, eye care routines, and appropriate diet plans to the individuals. It will also help users schedule an appointment with the ophthalmologist on a priority basis. Users with a severe and immediate need for medical assistance will be prioritized for appointments.
With the help of iLenz and partnered ophthalmologists,
we want to make an impact.
We want to make an impact.
We want to make an impact.
We want to make an impact in the AI for the health sector, normalizing retinal imaging at home.
We believe that through iLenz,
we can enable Jake and other 771 million people
in early detection of diseases
causing preventable or repairable vision loss.